What's up, 8th graders, and welcome back to 8th grade math. I am your host, Mr. Gilliard from Frazier K-8 School, but you can call me Mr. G. So today's learning targets are as follows. I can describe the effects of a rigid transformation on the lengths and angles in a polygon. Remember that word, rigid transformation. I can describe how to move one part of a figure to another using rigid transformations. If I have a pair of vertical angles and know the angle measures of one of them, I can find the angle measures of the other. And the last one is I can find the missing side lengths or angles measures using properties of rigid transformations. So today's materials you're going to need are tracing paper, graph paper, protractor, and a ruler. It might be pretty good to have some patty paper available as well. So when I said tracing paper, that's what I meant, patty paper. And it looks something like this. You remember us using these in school. Make sure you pull this out of your kit. It will be very beneficial to you today. All right, so here's some vocabulary words to know. So we're going to start with rigid transformation. And a rigid transformation is a move that does not change any measurement of a figure. Then we have our boy rotation. And rotation turns a figure about a point called a center of rotation. So wherever you are on that figure that you wanted to rotate from there, you just hold it at that point and then you turn, okay? A reflection places points on the opposite side of the reflection line. And then we have a translation, which moves the figure without turning or changing the size or the direction. Then we have clockwise. You have to remember that clockwise turns the figure from right to left. So when you look at a clock, you know which direction the clock goes, right? But then there's this bad boy we got called the counterclockwise. And he's going to do exactly the opposite of what clockwise does. So instead of going from right to left, he's going to go from, you got it, left to right. Good job. So let's remember that. And then last but not least, we have corresponding. When part of an original figure matches up with part of a copy, we call them corresponding. These could be point segments, angles, or distances. So it's kind of like taking a screenshot on your phone. So if you're on your phone and you saw something that was real cool, oh yeah, I remember this, I'm going to keep this. So you screenshot it. When you screenshot that, it's going to be the corresponding picture to the original one, unless you edit it, of course. But you get the point now. All right, moving on. So here is a grid showing triangle ABC, which is here, and two other triangles. We have CFG and EDB, okay? You can use a rigid transformation to take triangle ABC to one of the other triangles. Now, which one? Explain how you know. So what you want to do is you want to just pause the screen for just 30 seconds, and think about it. And then I want you to tell yourself, or just write it down somewhere, which one you think would work. Then I want you to describe a rigid transformation that takes triangle ABC to the triangle you selected. Go ahead and pause your screen now, and I'll see you when you return. All right, welcome back. I'm glad you made it back. So what I'm going to do is I'm going to demonstrate for you which triangle that I believe would work, and we're going to use the digital applets to do this, okay? So we're going to go ahead and transition to our digital applet. So if you are doing this online, then this is a great idea for you to know how to use the digital applet. Okay, here we are. So once again, the direction says here is a grid showing triangle ABC and two other triangles. You can use a rigid transformation to take triangle ABC to one of the other triangles. Now remember, rigid transformation, it doesn't change the size of the figure. Okay, keep that in mind. So when we look at this, triangle ABC is in green, right? So which one do you think this will look like, or this one will work? Now, if you said this one, triangle CFG, then I agree with you. And here's why. Because if we look at this triangle, DEB or BDE, whichever way you want to call it, it's fine. If you look at that, it is not the same size as ABC. So that's a dead giveaway, okay? So we know that this one would not work for what we are trying to do, okay? So now what I'm going to do is I want to see what type of sequence occurred in order for me to get triangle ABC to look like triangle CFG. Ooh, you heard that word, sequence? Sequence of transformations. We talked about that in our last video. Yeah, when you're doing more than one thing, right? Yeah, y'all remember now? Oh, I knew you would. All right, cool. So let's go ahead and see what we can do. So I am going to utilize my tools up here at the top. And the first thing I want to do is I want to create a vector. Okay, I want to create a vector because I want to tell B to move to F position. All right, so now that I did that, I'm going to select my tool that says translate by a vector. And what am I going to translate by a vector? This triangle. What vector am I going to translate it by? This vector. And boom, y'all, there you go. It's over there. So now we're getting close. We're getting close. So now we know we have a sequence of transformations because we moved it, not moved, but we translated it, or we slide it to the right, or we slid it to the right, whichever way you want to call it, right? We did that. But there's one more thing to do. And if you look at it, you have to know that there's going to be a rotation that's going to occur. So if you are familiar with angles, you can probably tell that it's going to be a 90-degree angle, but you have to think about which direction you're going to go with it. So you can go counterclockwise or you can go clockwise. But if you look at the position of this triangle, you should know that you're going to have to turn it what? Exactly, clockwise. So how many degrees you think we're going to turn? Did I hear 45? Or hear 60? Or hear 75? 90. There you go. So here we go. We're going to select the point that we want to rotate it on. We're going to rotate it on this point right here. Okay, so we select that point, and now we are going to rotate this triangle. Now watch what happens. When we rotate it, it's going to ask us which direction, and it's going to ask us how many degrees. So if we agree to rotate it 90 degrees clockwise, let's go ahead and do that now. Okay, so we're going to click, and we're going to change our degree to 90 degrees, and we're going to select clockwise. Now pay attention because that blue triangle is no longer going to be blue anymore. So I don't want you to be like, but I want you to understand what happened. Okay, here we go. Boom, y'all, it worked. So we did our sequence of transformation that took triangle ABC here, and we got our new triangle, A prime, B prime, C prime. But then we also had to do another rotation, which now give us our triangle A double prime, B double prime, and C double prime. Good job. All right, this next activity, rotating the segment, we are also going to transition to a digital applet. I'm going to show you how to do that here. And then we're going to transition to patty paper, where I'm going to show you how to do the next activity, which you will see on the next page, okay? And then that'll give you an opportunity to pause the video and practice for yourself. And you're going to match it up to mine and see if it comes out the same way. So here we go. Let's look at the digital applet first, so I can teach you what to do. And then we're going to transition over to our patty paper, and we're going to do the same exact problem that's on this slide, okay? All right, here we go. So our direction says to create a segment AB and a point C that is not on the segment ABC. Remember, segment is basically a line with 2 points on the end. Remember that. The segment is basically one line with 2 points on the end. It stops it right there. And then it says, 1, rotate segment AB 180 degrees around point B. And then it says rotate segment AB 180 degrees around point C. So remember that. So let's go ahead and create our points. We need points A, and we need point B. And we also need a point C. Okay? So you're there. Now we're going to make AB a segment by connecting our points. Boom, y'all. Very good. So we did exactly what it told us to do. We have segment AB, and we have a point C. Now, the first thing we need to do is rotate segment AB right here, or 180 degrees around point B. So that means we're going to put our point here. Now, if you was using a patty paper, you would trace segment AB and point C, and you would just put your pencil on B and you would rotate. But I'm going to show you that in a few minutes. But right now, I'm going to show you what you would do with the digital applet. So what you would do is you would select your rotate around a point feature. You will select the point that you want to rotate and select the line that you want to rotate. Okay, so when you do that, it now asks you how many degrees. Well, we were told to rotate 180 degrees around point B. Now, what I like about this one is it don't matter which direction you go, because it didn't say. It just said rotate around point B. So you can go counterclockwise or you can go clockwise. You're going to end up the same direction, so it really don't matter. All right, here we go. So we're going to just leave it like it is at counterclockwise, and boom, y'all, there you have it. Okay, now the next thing we need to do is rotate segment AB 180 degrees around point C. Okay, so once again, segment AB, we're going to rotate it around point C. And you probably thinking like, Mr. G, how are we going to do that? I'm glad you asked. Well, once again, if you're using patty paper, you would trace segment AB, and then you will put your pencil mark on point C, and then you will rotate that segment around point C. Okay, so here's what you would do with the digital applet. You are going to select the point that you want to be your center of rotation, select the segment that you're going to rotate, which is AB, not A prime, B prime. It says AB. Got it? So we're going to select that, and we're going to do it 180 degrees. Once again, it didn't tell you which way to go, but this time we're going to do clockwise, and you're going to see it don't make a difference. All right, here we go. Boom, yeah. Let's see if we can drag this graph down a little bit so you can see it. Okay. Oh, let's see if we can do it full screen. So anyway, as you can't see it, and I probably shouldn't have chose that area of the graph, but what I want you to think about for a second is what happened when we did each one of those transformations. So let's look back at number one, the first part. When we did this one, rotate the segment AB 180 degrees around point B, what happened? Look at it. It's still at point B, but it's just going the opposite direction, right? And it formed a straight line. Yeah, so it never changed the size, but all it did was it changed the direction in which it was going. Very good. And then another thing, if you look at the other one, all it did was it just moved it over here and it made it parallel. So it's not going to cross over at any time. It's parallel. It's going straight across the graph. So if I was to extend the graph where you could see it, you would see the line going way across the graph like that. Okay? So I just want you to keep that in mind. So good job. So now here's where we're going to transition to our patty paper. So don't be afraid because you're not going to see me for the next part of this, but it's okay. I'm still here. You're going to be able to hear me very loud and clear, but we're going to work on doing this on patty paper so I can help you figure out what to do. Okay?